Did you know that a galaxy larger than our own is moving toward the Milky Way right now? This galaxy is called Andromeda, our closest cosmic neighbour, and in a few billion years it will collide with our home. In this video, you will discover 50 fascinating and mind-blowing facts about the Andromeda Galaxy, facts that reveal how vast, mysterious and powerful our universe truly is. Before we begin, subscribe now and help this channel reach 1,000 subscribers as fast as possible, because the universe is endless and so is our curiosity. Now let's begin. The Andromeda Galaxy is known scientifically as Messier 31, or simply M31. It was catalogued under this name in the 18th century by the astronomer Charles Messier, who created a list of celestial objects that were not comets. Andromeda is classified as a spiral galaxy, which means it has a flat rotating disk, spiral arms, and a bright central core, very similar in structure to our own Milky Way galaxy. This spiral structure is created by gravity and rotation, causing stars, gas, and dust to organize themselves into massive curved arms stretching across space. Andromeda is located at a distance of about 2.5 million light years from Earth. A light year is the distance that light travels in 1 year, moving at a speed of about 300,000 kilometers per second. This means the light you see from Andromeda today actually left the galaxy 2.5 million years ago, long before modern humans existed. In other words, looking at Andromeda is like looking deep into the past of the universe. One of the most astonishing facts about Andromeda is its enormous size. It contains more than 1 trillion stars, which is at least twice the estimated number of stars in the Milky Way. Because of this, Andromeda is considered the largest galaxy in the local group, which is the small cluster of galaxies that includes our Milky Way, the Triangulum Galaxy, and dozens of smaller dwarf galaxies bound together by gravity. At the very centre of the Andromeda Galaxy lies a supermassive black hole known as M31 star, pronounced M31 star. A supermassive black hole is an object with a mass millions or billions of times greater than the Sun, compressed into an incredibly small space. This black hole plays a crucial role in controlling the motion of stars near the galactic core, and helps maintain the structure of the galaxy through its immense gravitational pull. Andromeda is not standing still in space. It is moving toward the Milky Way at a speed of about 110 kilometers per second due to gravitational attraction. Astronomers have measured this motion using a phenomenon called the Doppler effect, which is the same effect that changes the pitch of a siren as it moves past you. Based on these measurements, scientists predict that Andromeda and the Milky Way will collide in about 4 billion years, eventually merging into a single giant galaxy, often referred to as Milkomeda. Andromeda has a bright central bulge composed of older, redder stars. This bulge, often called the Galactic bulge, contains stars that are billions of years old, much older than the Sun, which is about 4.6 billion years old. The bulge's dense star population creates a bright glow at the galaxy's centre, visible even through small telescopes from Earth. Surrounding this core are the spiral arms, which are regions rich in gas, dust and newly forming stars. These arms are where much of the galaxy's stellar birth occurs, creating brilliant clusters of young blue stars. Within Andromeda's spiral arms, astronomers have identified thousands of star clusters, including globular clusters. Globular clusters such as G1 contain hundreds of thousands of very old stars tightly bound by gravity. These clusters are among the oldest structures in the galaxy and provide scientists with clues about the early formation of galaxies in the universe. Andromeda also hosts at least 14 known dwarf galaxies, small companion galaxies that orbit around it. Examples include M32 and M110, which are elliptical dwarf galaxies. These dwarf galaxies are gravitationally bound to Andromeda and have been partially absorbed or disrupted in past interactions, leaving streams of stars and gas extending into Andromeda's main body. Studying these companions helps astronomers understand galactic evolution and interactions. The galaxy's spiral arms are not fixed structures, but density waves where stars and gas move in and out while maintaining the spiral pattern. This is why we see bright star-forming regions, called H2 regions, within the arms. H2 regions are clouds of ionized hydrogen gas where new stars are born, often glowing vividly due to the intense radiation from young, hot stars. Andromeda's halo is a vast, diffuse region surrounding the galaxy, containing old stars, globular clusters, and a significant amount of dark matter. Dark matter is an invisible substance that does not emit or absorb light, but exerts gravitational force, shaping the motion of stars and the galaxy's overall structure. In fact, most of Andromeda's mass is made of dark matter, making it crucial to understanding galactic dynamics. The galaxy has a well-studied system of gas and dust. Neutral hydrogen gas, known scientifically as HI regions, spreads across the disk of Andromeda. These regions act as reservoirs for star formation and can be detected using radio telescopes. Molecular clouds, made mostly of hydrogen molecules, H2, are even denser and are the direct sites of new star formation. Andromeda's rotational speed is another fascinating feature. Stars in the outer regions orbit the centre at speeds of around 250 kilometers per second, faster than stars in the Milky Way at similar distances. This rapid rotation is one of the clues that helped astronomers infer the presence of dark matter, since the visible matter alone cannot explain such velocities. Andromeda has experienced collisions in its past. Astronomers have detected streams of stars that are remnants of smaller galaxies devoured by Andromeda. These stellar streams are evidence of the galaxy's dynamic history and help scientists reconstruct the sequence of past mergers, which is crucial to understanding how large galaxies like Andromeda grow over billions of years. The galaxy's light reaches us across vast distances, but it is not constant. Variable stars, such as Cepheid variables, fluctuate in brightness and are used by astronomers to measure distances in space. Observations of Cepheid variables in Andromeda were pivotal in the early 20th century, when Edwin Hubble determined that Andromeda is a galaxy separate from the Milky Way. Andromeda is part of the local group of galaxies, which contains over 50 galaxies, including the Milky Way and the Triangulum Galaxy, M33. Within this group, Andromeda is the dominant galaxy in terms of mass and size. Its gravitational influence affects the motions of nearby dwarf galaxies and even the Milky Way, shaping the dynamics of the entire group. Despite its enormous size, Andromeda can be seen from Earth with the naked eye under clear, dark skies, appearing as a faint, blurry patch in the constellation Andromeda. Its visibility has made it an object of fascination for humans for centuries, from ancient Persian astronomer Al-Sufi, who documented it in 964, to modern astrophotographers capturing stunning images with advanced telescopes. Galaxies like Andromeda continue to grow by accreting gas and merging with smaller galaxies. Star formation is still ongoing in its spiral arms, particularly in prominent H2 regions such as NGC 206, a massive star-forming region within one of its arms. These regions contain clusters of young, hot stars, some tens of times more massive than the Sun. Observations using multiple wavelengths, from visible light to infrared and radio waves, have revealed more about Andromeda's structure. Infrared studies allow astronomers to see through dust clouds and map cooler regions, while radio observations detect hydrogen gas and help trace the spiral arms and halo. The galaxy rotates in a disk-shaped plane with stars orbiting the centre in nearly circular paths. This organised motion contrasts with the random orbit seen in the halo, where older stars and globular clusters move in all directions. This rotation and the resulting spiral pattern are governed by gravity and angular momentum conserved since the galaxy's formation. Andromeda's collision course with the Milky Way is measured through careful observations of its velocity and proper motion. Scientists estimate that the two galaxies will start merging in about 4 billion years, a slow but inevitable cosmic event. During this process, stars will rarely collide directly due to vast distances, but the gravitational interactions will reshape both galaxies into a single elliptical galaxy, often nicknamed Milkomeda. Even though Andromeda is enormous, much of its mass remains invisible to telescopes because it is made of dark matter. Understanding the distribution of dark matter in Andromeda helps scientists refine models of galactic formation and evolution, and provides insights into the mysterious nature of dark matter itself. Andromeda has a rich history of scientific observation. In the 1920s, Edwin Hubble confirmed that Andromeda is not a nebula within the Milky Way, as previously thought, but an entirely separate galaxy, proving that the universe contains countless galaxies beyond our own. This discovery fundamentally changed our understanding of the cosmos. Andromeda contains numerous planetary nebulae, which are glowing shells of gas ejected by dying stars. These nebulae, such as the famous PNG 07 5.5 plus 0 1.7, shine brightly and help astronomers study the chemical composition and evolution of stars within the galaxy. Observing planetary nebulae also provides clues about the life cycles of stars similar to our Sun. Within Andromeda, supernova remnants can be found. Supernovae are explosive deaths of massive stars which release enormous amounts of energy and enrich the galaxy with heavy elements necessary for forming planets and life. By studying these remnants, astronomers understand the past stellar activity and chemical enrichment of the galaxy. Andromeda hosts active star-forming regions beyond NGC 206, where clusters of massive young stars emit strong ultraviolet radiation. These regions are often identified using H-alpha emission lines, a specific wavelength of light emitted by hydrogen gas, indicating intense, ongoing star formation. The halo of Andromeda is not empty, but contains faint streams of stars, which are remnants of smaller galaxies that were gravitationally captured and torn apart. These stellar streams, detectable through careful observations, tell a story of past mergers and interactions that shaped the galaxy's current form. Andromeda's dust lanes, dark regions visible in optical images, contain dense molecular clouds. These clouds are primarily composed of molecular hydrogen, H2, and act as stellar nurseries where new stars are born. The dust itself absorbs and scatters visible light, making the arms of the galaxy appear beautifully intricate. The galaxy's rotation curve, which plots the speed of stars versus their distance from the centre, reveals that stars in the outer regions move much faster than expected. This anomaly led astronomers to infer the presence of dark matter, an invisible substance that dominates Andromeda's mass and influences its gravitational behaviour. Andromeda and the Milky Way are both part of the local group's gravitational dance. While Andromeda is larger, the Milky Way exerts a gravitational pull as well, and over billions of years, these interactions will reshape both galaxies during their eventual merger. The stars in Andromeda vary greatly in age, while the central bulge contains ancient stars billions of years old. The spiral arms host young, bright, and hot stars that have formed relatively recently. This age difference creates a visually stunning contrast when observing the galaxy through telescopes. Some of Andromeda's stars are among the oldest known in the universe, formed shortly after the galaxy itself. By studying their composition, astronomers gain insight into the conditions of the early universe and the processes that led to galaxy formation. Andromeda's supermassive black hole, M31 star, influences nearby stars, causing them to orbit at high speeds. Its mass is estimated to be around 140 million times that of the Sun, making it significantly larger than the Milky Way's central black hole, Sagittarius A star. The galaxy contains millions of other stars similar to the Sun, some of which may host planetary systems. While no exoplanets have been directly observed in Andromeda, the sheer number of stars makes it likely that many planets exist within its spiral arms. Andromeda's interstellar medium, the gas and dust between stars, is composed mainly of hydrogen and helium, with traces of heavier elements. This medium provides the raw material for star formation and plays a crucial role in regulating the galaxy's life cycle. Observations with the Hubble Space Telescope have revealed the detailed structure of Andromeda, including its dust lanes, star clusters, and faint halo stars. These observations help astronomers map the galaxy in unprecedented detail, revealing its complexity and beauty. Andromeda's light spectrum shows the presence of many elements, including oxygen, carbon, nitrogen, and iron. By studying these spectra, scientists learn about the chemical evolution of the galaxy and the processes that create heavier elements through stellar nucleosynthesis. The galaxy's spiral arms are not static. Stars move in and out while the overall pattern remains. This phenomenon, known as density wave theory, explains how spiral structures persist for billions of years despite the motion of individual stars. Andromeda is approaching the Milky Way at roughly 110 kilometers per second, and this motion has been confirmed using the Doppler effect. As the two galaxies get closer, their mutual gravitational attraction will distort each galaxy's shape before they eventually merge. During the eventual Milky Way-Andromeda collision, most stars will not directly collide because of the vast distances between them. However, gravitational forces will trigger bursts of star formation, causing new stars to light up regions of both galaxies. The night sky as seen from Earth will dramatically change in a few billion years as Andromeda becomes much larger and brighter, eventually merging with the Milky Way to form a single giant elliptical galaxy known as Milkomeda. Andromeda's discovery helped humanity understand the universe on a grand scale. Edwin Hubble's observations of Cepheid variable stars in Andromeda proved that it is a separate galaxy outside the Milky Way, fundamentally changing astronomy and expanding our cosmic perspective. Despite being millions of light years away, Andromeda remains one of the most studied and photographed galaxies in the sky. It continues to fascinate scientists and space enthusiasts, reminding us of the immensity and mystery of the cosmos. The galaxy's name comes from Greek mythology, named after the princess Andromeda, who was chained to a rock as a sacrifice. Just like the myths, the galaxy captures the imagination of humanity, linking science and storytelling across millennia. Andromeda's structure, history, and motion make it a perfect example of galactic evolution. By studying this galaxy, astronomers gain insight into how large galaxies grow, interact, and eventually merge over billions of years, shaping the universe as we see it today. Finally, Andromeda reminds us how small and connected our Milky Way is within the vast cosmic web. Observing its stars, dust, black hole, and spiral arms inspires curiosity, wonder, and a desire to explore the mysteries of the universe, connecting us to the cosmos in profound ways. Andromeda Galaxy is not just a collection of stars and gas. It is a living story of cosmic evolution, collisions, and mysteries waiting to be discovered. From its trillion stars and ancient globular clusters to its massive black hole and streams of captured galaxies, Andromeda reminds us how vast and dynamic the universe truly is. If these 50 facts amazed you, imagine how many more secrets space still holds. Make sure to subscribe to the channel and join us on this journey through the cosmos, because together we can explore the universe, one fascinating fact at a time. Thank you for watching, and stay curious.